Anyway, so your major weakness I see is in understanding the waveforms. So please, you have to make your fundamental clear. This course is not about solving problem only. This course is about understanding the circuit behavior. That's the most important thing. Okay. I think your quiz will start at 12. Let me check. Yes, your quiz will start at 12. Okay. So this is the new topic. It's called DC-DC converter. So DC-DC converter is what? You have input DC, you have output DC. Okay. Input DC, output DC. What we have studied before? Input AC, output DC. Input AC, output DC. We can draw it like this also. DC, DC, both DC. So this is DC. This is rectifier. And you see, you generally when you see in the block diagram, they show like this, equal sign. That means this is DC. Okay. So here also DC, here also DC. So then what is the use of this? What we are trying to do here? Can you guess why we are having this kind of converter?
Stepping up or stepping down the voltage.
Exactly. Now, in case of AC system, you can have the transformer. You can have a transformer that you can use for stepping up or stepping down the voltage by controlling the ratio N1 is to N2. N1 is to N2. That's magnetic method of controlling AC. But there is power electronic converter also that does the same function. You have AC, you have AC. You give here AC, you give here, you get here AC. Okay. Now here what you have is fixed voltage and fixed frequency. Fixed voltage, fixed frequency. What you get here is variable voltage and variable frequency. This is called AC to AC converter. In AC to AC converter, there are two types of converters. One is called cycloconverter. Another is called matrix converter. If we get time, we will discuss this study. But so this is all power electronics. Okay. You see, you have AC to DC converter. We have already completed. Next, we are studying DC to DC converter, and then we can have AC to DC converter. Okay. And then we will also study another part that's called DC here, and we get AC here. That's called inverter. That changes DC to AC. Okay. So if you see, if you have a DC, you have only one parameter that you need to control. That is the magnitude of the voltage. Suppose you have 10 volt here, you want 20 volt here. We use boost converter to increase the voltage. If you have, say, for example, 10 volt, you want 5 volt. We need a buck converter. That is the converter that reduces the voltage. So you have only one function, that is called the changing of the voltage magnitude. That's it. But if you see, if you have AC conversion from AC to AC, you have fixed voltage, fixed frequency. We want fixed variable voltage, variable frequency. So that means two parameters we are changing, voltage as well as frequency. Both we are changing. Okay. Now, what you see in the case of transformer? You have voltage here, you change the voltage. But whatever is the frequency, you get the same frequency. You do not change the frequency. If you have 50 hertz here, you get 50 hertz here. So there is no change in the frequency. in the case of transformers. So that's the limitation of transformer. You cannot change frequency. Moreover, this is like, bulky. You have like a huge volume. So power converters, you can directly convert from AC to AC with both voltage control as well as frequency control. Here also in inverter also, you can control both voltage as well as frequency. Both you can change. Okay. In DC-DC converter, we need only control of magnitude. Now, what about the rectifier? Tell me what we control here. There is no frequency term here. There is no frequency term. Frequency is 0. So we get the variable voltage magnitude. Okay. Now, DC-DC converter, in general, there are 3 functionalities. One is called buck converter, that reduces the voltage. Output voltage is less than the input voltage. Boost converter, output voltage is greater than the input voltage. And buck boost converter, which is combined both functions, that is buck as well as boost. Okay. Now, there is another classification that's called isolated converter. Another is non-isolated converter. Now, what is the meaning of isolated and non-isolated? Isolated and non-isolated. Isolated means the input side and output side, they are magnetically isolated from one another. Electrically isolated also. Electrically and magnetically, they are isolated. Input side and output side. Okay. Input and output are magnetically and electrically decoupled. And electrically decoupled or isolated. So you need a high frequency transformer generally to make the isolation. This is input side, this is output side. And isolated converters that you are designing in your term project with high frequency transformer in between. And here this buck converter, boost converter and buck boost converter, they are coming in the category of non-isolated converter. So the input and output, they are not isolated from one another. Okay. They are coupled to each other. They are not decoupled, but isolated converter is decoupled from one another. Okay. These switching losses we have already studied earlier. So there are 2 types of losses. One is called conduction loss. Another is called switching loss. Conduction loss, when the switch is operating, you get conduction loss. And switching loss when it is turning on and off. So during turn on and during turn off, in both situation, there is a loss, power loss. That's called the switching loss. You see here, the voltage goes down slowly, the current increases slowly. So during this interval, there is some voltage which is falling and there is some current which is increasing. So since there is both voltage and current available during switching operation, so this is switching on operation, this is switching on, and this is switching off. So in both switching on and switching off, there will be some power loss that will occur, and that's called the switching loss because there is some voltage and current. Now when they are operating, you see there is high current but there is low voltage, only few volt. So there will be some conduction loss because of these 2 available, voltage and current product, but this is small conduction loss. And switching loss is like peak, it's like come every time it switches. Now suppose if it has 10 kilohertz switching and suppose it has 100 kilohertz switching. So in one cycle of fundamental, you can say, there will be less number of on and off. Here there are large number of on and off. So each time that switch goes on or goes off, in both the short duration of time, there will be some loss, and that is called switching loss. You keep on increasing the switching frequency, the switching loss will keep on increasing. Okay, so this is one of the parameters that you need to choose in designing the converter, because higher switching frequency means high losses, but the output voltage waveform or current waveform is much better compared to lower switching frequency. Okay, but it comes at the expense of the high switching losses. And conduction loss is when it is on and when it is operating. What is the loss that is occurring? That is called the conduction loss. Any question here? So now a DC-DC converter. A DC-DC converter, is used in many applications. All your, mobile phone chargers, the laptop chargers, they all have the DC-DC converters. Your television sets, all of them, they have some kind of DC-DC converter. So a DC-DC converter takes the voltage from a DC source and convert the voltage of supply into another DC voltage, to another DC voltage level. They are used to increase or decrease the voltage level. They are used in many applications ranging from milliwatts to megawatts. Then you see, you have used in different charging applications. Then you use for the electric vehicle battery charging. You use for electric vehicle powertrain applications, and that is drive applications. You use for DC motor drive applications, and you use a DC-DC converter in solar PV applications, and where you adjust the DC voltage and such that the solar PV operates at the maximum power point. So there are many applications of DC-DC converters. Regulated switch mode DC power supply. This is your isolated converters that you are using, flyback converter and push-pull converter and all those. They are generally used in the DC power supply. Then DC motor drives, you need a variable voltage to feed the DC motor. You use DC converter. Then you use in electric vehicle applications, and where you have the battery charging. So you need DC-DC converter to adjust the voltage, and that is required by the battery, and on the other side, the inverter. Then HVDC applications, high voltage DC transmission system, you need high power DC-DC converter. Then battery charging applications, you need this DC-DC converters. There are three types. This is called buck converter, boost converter, and buck boost converter. Buck converter, where you reduce the voltage, where you increase the voltage, and where you have both functionality. You can change it from the buck mode to the boost mode. Both mode are available. So average DC voltage must be controlled equal to the desired level. This utilizes one or more switches to transform the DC from one level to the another. So you need some power switch. Generally, we use MOSFET at high switching frequency for the DC-DC converter. The average output voltage is controlled by controlling the switch on and off duration. You see, you have the switch. This switch is on for some time and then off for some time. Is on for some time and off for some time. Now, suppose this is the on time, and then say this is off time, then this is on time, and this is off. So this is, suppose, the switching signal that is coming to the switch. So it turns on here and then off here and then on here. Now this time we call T on time, and this total time we call T, capital T, that is the sampling time or the switching frequency time, or switching frequency. Okay, so, and this is T off time. This is off period, this is on period, and this is the total period. So in this period from here to here, switch is on, then switch is off, then switch is on. So this is your one period. And if you take 1 by T, that gives you the switching frequency. That gives you the switching frequency. And from here to here, this is T on. And then from here to here, it is T off. Okay. Now, the ratio of T on to T off T on to T, you define as duty ratio. Yes. So this is how you define duty ratio. Okay. And T on by T is called duty ratio. And then T on plus T off is equal to your total period T. Okay. Your total period T. Now in place of T on, you can write dt. Then T off is equal to T. So how you get T off? T off will be equal to T minus TD, which gives you T1 minus D. So this period, on period is dt, and off period from here to here is 1 minus D into T. This is off period. Ask me if you do not understand the name.
Okay, all clear.
Okay. So this is your on period of the switch, and say this is the off period of your switch. The off period of your switch, and the duty ratio you define as T on by T. So you can say that this period is dt and this period is 1 minus D into T. Now when you have T is equal to 0.5, then T on upon T is equal to 0.5. Then in that case, T on will be equal to half of the total period. So if T on is half, what will be T off? T off will also be half. Okay. This is called 50% duty cycle. 50% duty cycle. So in the 50% duty cycle, on period and off period are equal. T on is equal to T off. So your switch is on for half time and it is off for half time. Then we say that duty ratio is 50%. Now suppose if I say D is equal to 0.7, that means for how long it is on and for how long it is off? Tell me.
For like 70% of the time period and off for 30%?
Yes. Yes. So when 0.7, that means 70% time the switch is on and 30% time switch is off. Okay. If D is 0.1, that means 10% on and 90% off. Okay. And T is equal to 1 by F. I will discuss these things later. Now, let us go to the DC-DC buck converter. What is DC-DC buck converter? Okay. So a DC-DC buck converter, you see, it has a network of switch. It has a network of switch, and then it has a filter, LC filter. It has a LC filter. So, and this is the DC source. This is the load. This is the DC load. This is the DC source. And in between, what you have is the switch and then passive filter. So for buck converter, the source voltage VD will be greater than the output voltage, or you can say that the output voltage is less than the input voltage. Okay. And let us see this LC filter. So we have already seen this LC filter before. So what is the role of LC filter? That if you have a resistive load, suppose if you have a resistive load and this is the voltage that you give to the resistive load, the current will be the same shape. The shape will be the same as that of the voltage, because this is I is equal to V by R. Okay. But if you have inductor, if you have RL load, if you have R and L inductance, then what happens that the current is like this. It starts shaping itself nicely. So because I is voltage across inductor is L di by dt. So di is equal to VL 1 by L integral dt. So it is integration. Current is the integration of the voltage. Current is integration of voltage. And as you know, if you have a square wave, this is your square wave, and I want to integrate it. So when you integrate it, it goes like ramp. It is like a step function. It's like a step function. It goes like ramp when you integrate it. So it become ramp. It become ramp. So here it become ramp. Here it become ramp. Then here ramp. Then here it become ramp like this. So this is how your current is improved. Your current is improved. Your inductor acts as a filter. It filters out the ripple. It filters out the ripple. You see here there is a large ripple in the current. This is the complete ripple. From here to here it is ripple. And the inductor, what it does? The inductor acts as short circuit to DC. L, because J omega L, if omega is, this is XL, omega is equal to 0 for DC, so XL becomes 0, so it acts as a short circuit to the DC. So it acts as a short circuit to DC. It allows the DC to pass. It allows the DC to pass, and it blocks AC. And AC is your like ripple. So it blocks the AC and it allows the DC to pass. So that means it smoothen the current. It smoothen the current. So you see, if you have high value of L, then the current further improves. It like this. And if you have very high inductance, then it will be like a straight line, like complete DC. It will be complete DC. Okay. And if you put a capacitor here, across the load, so what it does, it gives a constant voltage across the load. It gives constant voltage across the load. And it blocks DC. It only allows AC to pass. Capacitor blocks DC and allows AC to pass. That means the current that is coming out from the inductor, it has the DC component and it has some ripple. It has although it has filtered out some ripple, but still there are some ripple that is remained in the output current of the inductor. So that ripple current will very easily pass through the capacitor. So the ripple current passes through the capacitor. So the average current, the DC current that remained, that goes into the load. And this is what is our desired condition, that I want the DC to pass through the load and the AC to filter out, or ripple to be filtered out. So how we filter out the ripple? Ripple is filtered out by means of the inductor and then a capacitor. So this inductor will allow DC to pass, but there will be some ripple here, and that ripple will pass through the capacitor and it will go to the ground. So the average current that will pass through the inductor is same as the current that goes to the load. The average current that is passing through the inductor, the same current goes through the load. Because the ripple that was here, the ripple was filtered out by the combination of inductor and capacitor. The average current through capacitor is always 0, and the average voltage across inductor is always 0. So the average current through the capacitor is 0, and the average voltage across the inductor is always 0. Okay. So now this is the circuit of a DC-DC buck converter. You have a switch here, and then you provide a diode here, and then you have filter. This LC is just a filter, and then you have a load. Okay, so this is called the switching network. This is the switching network, and this is the filter. And that was shown here as the block. That you have a switching network and you have a filter. And it is called passive filter because L and C you are using, so it is called passive filter. There is also called active filter. If you are using MOSFET and IGBT, and then you filter out the ripple, that is called active filter. So that active filter is not the part of this course. It's only the passive filter. So what is here? This is my DC source. Then I have a switch. The switch can be MOSFET, IGBT, or BJT. And this is LC filter. This is LC filter. This is load. This is called the buck converter. This is called the buck converter. This is called the buck converter. Okay. We will discuss the operation of this in the next class. So now you get ready for the your quiz.